Yeah, hi guys. So this is the first question of the assignment. It's the sensitivity analysis. Usually it's a huge part of the final exam. The question on sensitivity in the final is usually worth a lot of points. There are two sections. If you look at the assignment, there is the variables section and there is the constraints section. Variables, there are four variables. You have the name, its number of sectional, love seat, chassis, and daybed. For the constraints, you also have four. You have the name, sewing, finishing, fabric, cutting. You have all kinds of numbers. Now, when you see a question like this in the exam or anywhere, first thing you need to know is this a profit question? Is it a revenue question, cost question? If you read the question, you'll see that they're trying to maximize profit. So once you know that this is a profit question, in the variable section, objective coefficient would be profit period. So if it's a profit question, then your objective would be profit per unit. So sectional will give you a profit of 1,000. Love, 2,000. The bed, 3,000. So all of these are dollar values and they represent profit. All of these are actually going to be profit or dollar value as well. So if it's a cost problem, this would be cost per unit. If it's revenue, revenue per unit. Usually it's a profit question that they ask, so this would be profit per unit. So if you read the first part of the question, they tell you what's the solution and what's the maximum profit. So solution would be how many units of each of the variable they need to produce. And that's your final value. So they need to produce 0 of this, 337 of this, 0 of this, and this number. I'm rounding this everything to 2 decimal places, but they use a lot of fractions here. So make sure that you use the same number of fractions that they're using. So in A, this is what you say. The company should produce zero of sectional and chassis. They also need to produce 337 point, it's exactly 786517 of love seat and 3.370786 of David. This is called their production. Now part 2 of the question, okay, this company, they have 4 variables, 4 products, final value is this. This is how many units of each they should produce. The second part, if they do produce this, how much money can they generate? What's their profit like? To do profit, you need to take each number here times whatever the profit per unit is. So they're making 0, each 1,000, so 0 times 1,000 is nothing. Then you have this number times 2,000, then 0 times this, then 3 times this, and then you add this all up. That would be your profit. So profit is going to be 0 times 1,000, 337.08 times 2,000. But again, use the complete number. I don't know, I don't have it with me. Sorry, I don't want to write it, so it's 0.0786. I'm only using two decimal places. 0 times 2000 plus 3.3, and use whatever number of decimals they're using times 3000. I want you to do it with the correct number of decimals. I'll tell you finally when you do it. I'll calculate it using my calculator here. I'll tell you finally when you do this what you expect the final answer to be. 786517 times 3000. It's going to be, I'll write it here, final answer would be 684,269 and about 63 cents. So do it, make sure you end up with this number. That was A, part 1 and 2. So we'll look at B. The B question, which constraints are binding? Constraints were here, and there are 4 of them. Which of the 4 binding? Now, there is something called final value, and there is constraints right-hand side. This is basically what's available, and this is what's being used. So for example, sewing is in minutes. So you have available 50,000 minutes, they're only using 30,000 something. Finishing is also in minutes, available 12,000, you're using 12,000. Fabric is in meters, available 10,000, you only need 7,500. Cutting, available 300, and you're using, 30,000, and you're using all 30,000. Now, when they say binding, if these two numbers match, then it's binding. So binding, that's B. Constraints are finishing, and cutting, since final value matches constraint right hand side. Good? Okay, the C question. Would the solution change if the amount of sewing time was reduced by 1,000? So you see this sewing here. Available is 50,000. They want to reduce it by 1,000. Would anything happen if they do this? No. But before you do this, this is anytime in the constraints when they tell you you get something or you lose something, you need to check. Losing 1,000 minutes sewing. Is that okay? So we look here, allowable decrease. Yes, you can decrease by 19,376 if you like. So 1,000 is okay within allowable decrease. So first of all, we accept the change. So losing is okay, it's within the limits. Now, to figure out what the impact is, you take this loss of 1,000 and you multiply it by whatever the shadow price for sewing is. In this case, it's 0. The answer is 0 because anything times 0 is 0, so it's no impact. Another way of looking at it, you see available 50,000. You're only using 30,000. So if the available, if you lose 1,000 from here and the available becomes only 49,000, you're not going to be affected because all you need is 30,000. So we know that losing 1,000 here would have no impact. So that's the C question. Now we look at the D question. Suppose 2,500 meters of fabric is found to be damaged, cannot be used. What's the total impact on profit? Well, first of all, I think this is a typo. I don't think that the number 2,500 is correct, but it's too late to let them know. So you lose 2,500 for fabric. So first of all, would you accept the change? No, you wouldn't accept the change because it's more than the allowable decrease. So losing 2,500 meters of fabric is more than allowable decrease. Usually, if it is not more, if they say, and that's I think what the question was supposed to be just 2,000. So 2,000 you would say yes, it's within range, and then you do the same thing we did for the previous question, you multiply it by the shadow price. But since you lose more than the allowable, all you need to know that profit will go down. To know exactly how much profit will go down or how much you lose, you need to take this problem and do it again in Excel. I don't think that question wants you to do it again in Excel. In fact, you don't have enough information to do it in Excel, so you only indicate that profit will go down. Okay, so we go to the E question. Now, suppose you can get more finishing time, and you have to pay money for this. So finishing, you get more finishing, and you're gonna pay 3,500 an hour. Now remember, all these constraints for finishing, cutting, and sewing, they're all in minutes. So when they say in E that you get 3,500 an hour, let's see how much, I'll change the marker. Let's see how much this is a minute. So you divide this by 60 to see how much this is in minute. It would be $58.33 a minute. Now listen, if this number more than the shadow price, it's not a good deal. The shadow price for finishing is 50. It's not a good deal. So because you're gonna lose $8. In order for this to be profitable, this is cost. Remember, shadow price is how much money you can gain. This is cost. It costs you 58, but you get $50. It doesn't make sense. You're losing $8. So you say more than shadow price of 50, we lose $8.33. Not a good deal. Okay, we look at F. They give you another question similar to this one, but this time they make it a good deal G. Now, oh, F, sorry. Additional cutting time, so now they're talking about the cutting time, available at $100 an hour. So the cost here, $100 an hour. If you do the math and divide it by 60, this will give you about $1 and say 67, 66 cents. If this is more than the shadow price, it's not a good deal. But this one, see, it costs you $1.67. You make $2, it's a good deal. So, less than shadow price of $2. It's exactly $2 and about 808988764. So gain is, so you gain the difference between them. So what's the difference between this number and this number? You're actually going to make about $1.14 per unit. Then good deal. Okay, we go to the next one. Next one is the FG. Love seats over here. Love seats have had great sales, and it's been possible to increase the price such that the profit now is $2,100 per couch, should the quantities change. You see, Love Seat, they're actually producing 337. They make $2,000 profit a unit. They tell you it's possible to increase this by 100, make it 2,100. Would that be attractive enough for you to produce more of this and less of something else? We check. This is G. Increase, if you go from 2,000 to 2,100, there is an increase of $100 profit. And the increase of $100 is just within allowable increase. E plus 30 means infinity. You can increase it by infinity. So it's within allowable increase. If you, now listen carefully. If the change here is within, there is no impact on production. So again, for the variables, when they tell you you increase 100, you increase 200, you lose 100, you lose 200, if that is within limits, anytime you're within your allowable increase, allowable decrease, then there is no impact here. Good. So there is an H2. Top line furniture really wants to make more of this. What's the impact? Now, we know that it's not good for the company to produce this because according to the final solution, the best solution is to produce nothing of this, 337 love seats and 3. So if they come and force you and they tell you, hey, you need to produce some of this, or you need to produce some of this. So you know that it's not good for business, you are losing money. Question is, how much money are you losing if you're forced to do this? There's something here called reduced cost. Don't worry about the fact that it's cost. Excel always calls it cost. It means anytime you produce this, you're gonna lose 1250. Anytime you produce this, you're losing 1601. So for every case produced, we would lose 1250 profit. I, retailer has asked the top furniture to make a new kind of product, a fifth product. And they want to know if it's a good product or not. They're gonna sell this new product for $4,500. It requires 14 fabric, 75 cutting, 60 minutes sewing, and 65 finishing. Okay, so to actually know if it's a good product or not, let's see how much it will cost you. 14 fabric, and each one shadow price 0, so there is no cost for fabric. 75 cutting, and cutting has a shadow price of 2.80, say 9, plus you're going to also need, according to the question, 60 minutes sewing, and each one is 0, and 65 finishing, and the shadow price for finishing is 50. This will be the cost of making this product. So the cost of making this product is going to be $3,066.75. So your net profit in this case, if you're gonna sell it for 4,500 minus 3460675, you're going to make profit of 1,039,325. So that's a good thing, good deal. So if you do the math and it's a positive number, then it's a good deal. But if you do the math and it's a negative number, it's not a good deal. Now, I'm done with the first question, but I just noticed that that I missed. There was one question that I didn't complete. I did half of it. It's F. When it was $100 available for cutting, the second half, should they proceed, and how much money they can get for cutting. So I'm gonna go back to F. I'm gonna do the second part. So F, second part of F, how many minutes or how many hours they can afford. You see, it was talking about the cutting. Yeah, you see the cutting here? Allowable increase is this. So you can get 514 and the exact number 2857143 more minutes, which is equivalent to, if you divide it by 60 to know how many hours, $8.5714 hours. This would be the complete answer for the first question. I'm gonna stop this video. That would be part 1. Part 2, I'll do question 2.